Hello. I hope you can hear me. We are going to start now the webinar. I think Iñigo is connected, but I see in the label is the name is Pedro Lerga, so there's something wrong. Okay, so welcome to this a new webinar of AEMER. AEMER is the Association for Companies involved in the maintenance of the maintenance of renewable energy installations. I am Alberto Ceña, the General Secretary of the association. This webinar is I'm going to share the presentation with Iñigo Vázquez. Iñigo, are you there?
Yeah, I'm here, Alberto. Welcome to everybody.
Okay, so many of the participants are Spanish, but as far as the training course is going to be in English, we are going to present this webinar in English, but you can send us the questions, any doubts, also in Spanish, and we will send our answers in Spanish. There are two options to send the questions, the chat and the queries. We would prefer to concentrate all the questions in the chat to avoid some dispersion we have suffered in previous webinars. Okay, so we have 1 hour now to present a training course. We are now preparing with the support of InnoEnergy, and also with the participation, with the involvement of Router for all the training material. So this is a typical activity of InnoEnergy to promote the innovation in the renewable energies sector. And besides the support to specific projects, they are also participating in different training courses. So now we are going to present the course, but also we are going to present the main challenges of this very modern activity of life extension and repowering. What is the summary of the presentation? Now we are going to present in 5 minutes what is the Windex REP spoke turning project. The project has different modules, and this is the reason why this complex name, Windex REP. I will also introduce the main challenges of a life extension and repowering. The key elements on the lifetime, I'm going to share this with Iñigo. And the key elements of the wind farm repowering, I'm going also to present this with Iñigo. So going ahead, because we have not too much time, what is the main objective of our Windex REP project? I want to insist that this is a very innovative initiative, because there is no other courses in the world for handling these issues about life extension or repowering. So we are this is rather new, and we want to thanks to this support received by InnoEnergy. Which are the main objectives of the course? The main objectives are to learn about the most common methods to evaluate the remaining life of an installation in operations, to propose a better working procedures to guarantee and extend the life of the asset in the best operational conditions, to evaluate the legal and economic boundaries regarding the permitting procedures and the sale of electricity, especially in the case of merchant plants. Now everybody knows that the trend in the market is to sell the electricity in a merchant method, not because the premiums are not anymore existing. To define the contractual and financial barriers for the installations, to select the best procedures. We are entering already in the repowering, to select the best procedures to dismantle a wind farm regarding the final use of the wind turbines and the main components, and to learn about the most appropriate methods for the recycling or reuse of the machinery blades and main components. So those are the goals of the training course. Now we are going to present which are in our point of view, especially from the maintenance point of view, what are the key elements of these challenges for the future. So as I said, it's a very innovative training initiative where we integrate all the economic, technical, and legal aspects related to extension of life and after several years of operation. It will allow also the introduction of advanced operational schemes in a new sector that now we are reaching years of expected useful life. We are taking the experience mainly in Spain, but also in the other parts of Europe, because as you know, Spain and Germany and Denmark are the countries where we are most advanced in the use of extension of life and repowering. The project is addressed to mainly increase the existing skill and is complementary to other training. So in all these cases, it's important to be practical, but with this online course, we are going to complement other training initiatives. As I said before, now the existing wind farms are becoming older, especially in the pioneer countries. Denmark, Germany, and Spain. The useful life was originally 20 years, in accordance with the standards, IE 71400 design certification, and decision about the procedure to follow extension of the remaining life or repowering is not easy, and it depends on many factors, as almost everybody knows. What happens with all wind turbines once the wind turbines are becoming older? We have different options. The first is to keep the operation a normal operation until the expected life, and afterwards, and after these 20 years, to dismantle the wind farm or let it die. This is very unusual. Normally, once the wind farms are reaching 20 years, everybody thinks what is going to see the following step. Repowering is dismantle and replacement with new and larger wind turbines. Everybody knows also that the reproduction with a new wind farm, it could be double of the existing wind farm. So repowering is a logical trend, but the problem is you need to invest. So the final option is the lifetime extension. This is becoming very common here in Spain, but also in the rest of European countries, is just to extend the life, keeping the maintenance or improving the maintenance, because it's true that for the life extension, we need to keep attention in the structural components, many foundations, tower, and platform. What elements should be taken into consideration? The regulatory framework. What are the procedures to follow with the operation of the wind farm? In some cases, we can also, to increase the energy output in wind turbine has been underloaded. We can also take into consideration to install some components can increase the production. What is the life already consumed? The availability. It's true that in practice the availability is becoming more or less stable. It's not being reduced as could be expected at the beginning. So now I cannot say that it is still 97%, but this is very high. And also, and this is very critical in this sector, what is the financial starter or the value of the old equipment in the repowering scenario? The trend is this is coming from the America, but this is also common in the other parts of the world. The trend is all the turbines are increasing the diameter. The power is more or less stable, and also the tower height is more or less stable. The way to increase the production is to increase the diameters. Now it's very common to see, well, it's not common, but this is turbines. We can see turbines of 132 meters, 36 meters, and only for 3 years ago, nobody guessed this could be the situation. But the power is still between 2 and 3 megawatts, and the height is still around 100 meters. This is the case, I said before, comparing a Nordex N80 with a Siemens Gamesa G114. in normal conditions, the increase of production is around 40%. But if we take our G132, we can increase another 40%. So comparing Nordex N80 with Siemens Gamesa 132, production could be is going to be the double. So now this will affect to the decision to repower the wind farm. So now about the lifetime extension, I leave Iñigo. I will also intervene in some points. I need to add something complementary.
Okay, thank you very much, Alberto. And once again, welcome to everybody who has joined this webinar. As I have seen in some of the messages which are coming when Alberto was talking, it seems that the screen is not very clear. I mean, do not worry, because if there is anything that you would like to know, we're open to share the information to all of you. Okay, so going back to the lifetime extension topic, I mean, this is really one of the key issues that we have right now, at least in Spain, and I think it's a really worldwide issue up to now. Well, I would like to go to the next slide, but Alberto, I cannot go to the next slide. Alberto, you have now, okay, I got it. For some reasons, I don't know, seems that I cannot go from one slide to the other. Alberto, you should share with me the capability to move slides from up and down. Well, while Alberto is trying to fix this problem, I will go ahead. And the fact is that, as I was saying, the lifetime extension topic is one of the big issues we are running now, mainly because, as you know, we have a big fleet in Spain. Most of the fleet are not still in the 20 years life, but they are very close to them. And, well, we are really facing the issue that that for different reasons, still repowering is not installed in Spain yet. We have really some difficulties in Spain with the administrative works, and still the revenue that we get from the projects are not 100% as we expected, because there was a change in the regulation. And the fact is that we have decided that maybe there could be one option to extend the lifetime of the projects. What do we see in the and this we can see it in the next slide when Alberto put it together, is that we have a big fleet of small turbines where, for sure.
Iñigo, can you increase the volume of your computer?
Yes, I think it's in the top, but I will try. Okay, I hope that now better. I have put it to the top, and we have faced that we have a fleet of turbines which up to now they are around 300 and 900 kilowatts. The ones that we have to extend the lifetime of the turbines, and really size of wind farms which are not still too big to really make profitable this kind of life extension. As Alberto was mentioning before, what do we really need to focus on? I mean, what is really important is that right now still we don't have any kind of certification which can guarantee the fact, the extension of the life of our wind farm. And okay, it seems that I have to take the control of the tour. Oh. Alberto, can you go 2 slides ahead, please?
One.
The next one, please. So, and the fact is that one of the big problems that up to now there's not the real certification of to extend the lifetime of the wind farm. Still, we are working different companies. We are trying to work in find out how to certificate or how to get a certification from one statement to really extend the lifetime of the wind farm. But we have to consider as well that when we talk about extending the lifetime of our wind farm, normally we have to do it turbine by turbine. I mean, we started really thinking on different models of turbine to extend the lifetime of the turbines. But now with the experience, what we are realizing is that we go deeper thinking on extending the lifetime of the wind farm. But now we are going even deeper, really extending the lifetime of wind turbine. We have seen there's really a demand to work in single cases in specific turbines, really to understand how can we really extend and how can we guarantee that the lifetime extension program that we want to establish are really in accordance to our calculation. Go to the next one, please, Alberto. In that consideration, we have to think, okay, what is really our value? What is really what we have to invest really to extend the lifetime of our wind farm? What is our critical points that we have in our wind farms or in our turbines? And really to understand what is the real behavior that we have in our wind farms. There's really a lot of points that we have to consider before we start with a lifetime extension program. Alberto, go to the next one, please. And as I said, Alberto, next slide, please. As I was mentioning before, we have to analyze the wind farms in an individual base. We cannot analyze it as in a global fleet. We have to understand that we are working with turbines which the load methods were done several times ago. So we have to really implement new load measurements and new load methods that are in accordance to the new calculations that we have up to now. And we have to really analyze in detail what data have we gathered during the historical behavior of the wind turbines, and which are the status of our critical components. We'll see later on that our main components which are under risk are mainly the main components, as Alberto mentioned before, like foundation, towers, generator, gearboxes, blades. And for that, we definitely have to improve via retrofits, via software, different options in order to be able to improve the lifetime of the turbines. Next one, please, Alberto. Which are Alberto, next slide, please. Thank you. Then, which are the main phases that we have to go through when we talk about the long-term lifetime extension program? The first one is really to gather the data that we have. No, really, one of the main problems that we have in our business is that we are producing a lot of data, but we are not analyzing all the data that we could. I mean, we have really thousands of information coming from different sensors and really putting together a lot of data, but we are not 100% using all the historical data in the right way. That's why up to now there's a lot of programs, a lot of projects going on in order to really understand the data, the historical data that we have had from the real beginning of the wind farm. Another one is a big consideration is how do we have performed the maintenance during the lifetime of the wind farm. That's why it's really important to understand what have been really the gaps, the technical gaps that we have had during the lifetime of the projects. And another part that we have to think about is that we have to carry out different inspections during this extension program. It's not only really to improve our turbines with several retrofits and whatever. During that process, we have to carry out different inspections, regular inspections, and somehow we have for sure to make it profitable. As we can imagine, I mean, the most profitable will be as bigger as will be the turbines. I mean, if we talk about some turbines that we have in Spain, which are pretty small, from 300 kilowatt, I mean, the investment that we have to do for this kind of turbines should normally it's not in accordance to the investment that we have to do with big turbines. And the result, the amount between one and the other are really more benefit as bigger it is the turbine. Okay, Alberto, go for the next slide, please. No, the one before, please. Next. Okay, here we have seen that there is, as I said, we face the project in all different phases. First, we call it gathering data, which, as I said, we will have to understand the behavior of each turbine in individual basis. Therefore, we have to analyze all the alarms, logbook, failures, whatever. Then we have the second phase, which should be the key main components analyzed. The third one should be inspection campaigns, and the fourth phase should be refurbishment and criteria definition. If we talk about which are our main issues in our main components, so you will see in this slide, even though it's not very clear, but over there you can see that in the main components, there's the issues should be more or less the same. If we talk about, for example, the PLC, our main issues comes from the algorithm capabilities. I mean, keep in mind that some of the PLC that we have installed have more than 20 years. The new software demand new algorithms with, it's required that our PLC should be somehow improved. And if we talk about the generator, our main issues up to now are related to isolation degradation. Normally, it's also we have some problems with the mechanical failures, mainly with the bearings or even with the slip-rings. We have some problems, and for sure we have also in degradation in the power cables. So for that, for sure we will have to improve. We have to monitorize in order to really extend the life from 20 to 30 years, as well as the cooling system. And in the tower frames, normally our main problems comes with the fatigue, rust, and lack of live odometer knowledge. And over there, we'll have to go through inspections, plans, diagnostic, and prognostic odometer improvement, repairs, and so on. Gearboxes, of course, that's a big topic we are facing on. We are facing right now problems with bearings and planetary. Mainly problems are related to mechanical issues. And for that, definitely we will have to improve our conditioning monitoring. We will have to improve and install predictive systems to go ahead, and we'll have to improve even the design of bearings, where we are facing that the design that we use on the real beginning are quite old for the new, compared to the new types. Okay,
wait a second, Iñigo. It seems there are some problems with the screen. Everybody is writing there is some problems with the screen. I don't know how to, because people say that it's not possible to see the text, but I don't know, because in the past it has we have not had any difficulties for this.
Well, you see that the words are pretty small. You know, we have put so many information in order to give as much as more information. But
I have no problems to see it. I don't know why the rest of the participants have some difficulties to see the texts, but I don't know how to resolve it. Well, okay, go ahead, because I don't know how to. This is the first time it happens. I don't know what is happening now. Okay. We're going to share the presentation. Don't worry.
Yeah. I mean.
Hey, go ahead.
Yeah, I will go ahead. I mean, we are running a little bit out of time, so I will try to go a little bit faster. I mean, over there you can see what is our failure expectation that we have concerning the mainframe and the main components. When you receive the presentation, because as far as I have seen the screen, it's not very clear. Over there is divided for a certain type of turbines, which are our expected cost for the main components. As you can see, during the first 15 years, I will say it's not exactly flat, but it's very close to flat, our expectation to for cost concerning main components. I mean, we're talking about that our experience goes around 25,000 euros per megawatt during the first 15 years of the lifetime of the turbine. But really, from the year 15 to the from year 40, for instance, in a case that we don't do anything, I mean, the cost expectation for the main components really increase a lot, and that's why, as you see in the screen, really we expect to have, if we talk mainly, for example, about the main components, especially gearboxes, more than the double of the cost related to O&M. That's why we have to, when we talk about extending the lifetime, we have to consider some modification that we have to do in the design of the components in order to avoid that this cost goes so high. Next slide, Alberto, please. Very important, as I said, that we gather the data, we put it together with our own conditions, O&M conditions, and we have to put together also which is the design that the turbine was done on that time. I mean, as Alberto was mentioning, it's really important that that we work under two models. First, the load measurements data, and then the historical data that we are gathering during the lifetime of the projects. And for sure, keep in mind that the conditions of each wind farm, even each wind turbine, are completely the same. I mean, we can have two turbines in the same wind farm with the same model, same time, same supplier, everything the same. But even in the same wind farm, if we start to analyze both parts, the loads and then the historical data, the behavior of the wind farm, the wind turbines will be completely the same. That's why for each turbine of this wind farm, we have to adapt a life extension program in an individual mode. We cannot make calculation in the whole fleet of the turbines of the wind farm. Then the next one, please, Alberto. Well, that's a summary on the different data that we have to gather. Mainly data, as I was mentioning before. On one side, turbine coming from the different sensors that we have in the turbine, but in parallel we have to also analyze the different performance of operation that we have had during the historical data of the wind turbine. Important is the next one, Alberto, please. This is a summary on what we have talked about. Next one, please. Is when we talk about different inspection that we have to carry out of during the lifetime of extension. If we go to the next slide, we will see that we have for sure. Next slide, Alberto, please. We have to check it out on the mainframe, the hub and the tower. Our experience that there is appearing different cracks. So we have to, through penetrant liquids or visual inspection, to understand if there is cracks in the mainframe. Also through visual inspection, we should check if there is cracks as well in the blades. One of the big problems that we have in different type of turbines in Spain was concerning the cracks in different points of the tower and even though in the mainframe. So we have to go deeper, making ultrasounds, and foundations are also a very critical part that we experienced that in several wind farms there is there have been as well cracks and the different problems. So we have to take samples or extract different type of samples and analyze in detail what's really happening on the foundations. And oh, now I see a little bit too late, but now it seems that we can see the screen much better. For the gearboxes, we will have to go through video endoscope, oil analyze, and as well as vibration analyze. And in general, we will have to check it out through visual inspections, the status of the turbine itself. I mean, it's also recommended to carry out through thermal inspections the status of everything that has to be with electrical components and so on. Please go to the next slide. This is a summary on different examples of inspection that we have done it. And for sure, what is really important over here is, and we will end with this with the lifetime section, is go to the last slide, Alberto, please. Well, it's our investment over here. I mean, really, here we have to put together on what will be our investment of our revamping. I mean, when we invest different money in the turbine, we call it revamping. So for sure, in each individual case, we will have to invest different money, but the amount that we have established will depend for sure on the conditions that we have analyzed during the study case that we have done it during these 4 phases that we have explained up to now. Okay, Alberto, if you want to go ahead with the repowering, then we will come back to the lifetime extension.
Okay, well, I'm going to mention, as we have had, sorry, I had some difficulties because well, I took the control and it was some problems with the presentation. Now I think it's much better. Well, about life extension, to summarize what Iñigo said, so this is the trend in the market. It's true that all the companies, sorry, Nacho, the next one. This one. No, the first of repowering, Nacho. First, the previous. Okay, about this extension. life extension, the idea is to collect data about the operation of the wind farm and to use different kind of models to present, to simulate the conditions of operation and to evaluate the remaining life of the wind turbines and of the wind farm. So in the training course, we are going to present the different approaches existing now in the market, where some of the teachers are coming from the sector. They are using models for doing this kind of evaluation of the remaining life. And also in the course, we are going to show how this data should be collected. And once the simulation is being done, the final result of this simulation will be used to adapt or to introduce some changes in the maintenance program, different methods of maintenance. As we are observing now in the market, it's still very shy, but it's going to be different probably in the future. The owners of the wind farms are taking into consideration the data collected and the results of the simulation models to define new methods for the maintenance of the wind farms. So entering now in the repowering. So as I said, new wind turbines can increase the energy in 40%, even more. We will see later the case of Malpica wind farm at the north of Spain, and the production has been double. So there is an increase of the generation. And keep in mind that normally in Spain, Denmark, and Germany, the wind energy started in the areas with better wind conditions. So it's a chance to optimize the use of these real good wind conditions. Additionally, there is also a reduction on the OPEX. The new wind turbines request less manpower, less spare components, and there is also the possibility to reduce the OPEX. And one of the points is a certain debate in the sector is about the capex. How much is the reduction of the capex using, as I said, as I mentioned in this slide coming from Enel, from the existing wind farm, we can use the substation, and the high voltage line can be reused. Always, if the wind farm has the same power. So we have seen here in Spain that there is one of the arguments to promote repowering is to increase the power. So to increase the power of the wind farm. So then it's a good argument to convince people to repower the installation. Also, the control building can be reused, but sometimes it's a modern installations. A new warehouse could be necessary, and the spare components are bigger, and then the warehouse could be not big enough for stocking for the store of these components. The internal roads, there are part of the roads can be used, but the curves, the radius or curvature of the paths or the way of the roads are not should be increased, because the blades are going to be bigger, and then the curvature is not enough. And also the slopes, the weight is heavier wind turbines, and then the slopes are not big enough, or even how the construction of the roads, so the materials to be used in the roads are going to be different. The internal grid is not can be used, and also so in total, the saves comparing an existing wind farm and non-all wind farm is around 10–15% of the savings. In some cases here in Spain, one of the arguments we will mention in our training course is going to be also the reduction. There's in some countries. There is a canon paid by the number of turbines. If you can reduce the number of turbines, then you will also improve the economic effectiveness of the projects. So what is each case should be an ad hoc evaluation. And in principle, the repowering can be only used if there is a clear increase of generation. In principle, it's true, but sometimes it's not true due, among other things, to the reason mentioned afterwards, the environmental. Some of the wind farms are installed in areas with some kind of environmental protection, mainly the Natura 2000 network or some specific environmental protection, and then it's not possible to increase the number of turbines, and the number of turbines that can be reduced. The access of the, well, there is an increase of generation. It's the case, for instance, of the Ceasa wind farms at the south of Spain. It was I think the repowering could not be done if the total power is not increasing 10 or 20%. Another thing is the regulatory framework. Now this is important, but it's not the same in the past. Now we see around the world there are many plants are offering very low prices, or through auctions, or directly as merchant plants. And then, so the regulatory framework is not so critical that it was in the past. And of course, it should be a complete agreement between all partners, and financing is also guaranteed. So we are here presenting some kind of conclusions of what happened with repowering. It's true that in the course we are going to present cases with different approaches, different methods to evaluate the options before to decide the repowering. But normally for existing sites with really well wind conditions and with the high spot prices in the electric market, so repowering could become very most popular in the future. But I want to insist that here we are presenting some general ideas, but in the training course we are going to explain about the methods to about the trend. There's a question here from David Hernandez about this methodology to calculate the price of the old machines. So there is not a clear method, because in the experience in the past, normally when we made the financial calculations in the past, we estimated, and it was the case of Ceasa in Tarifa, that the cost of dismantling the turbines was covered by the price of the by the turbines in the secondary market. But this is not the case of Malpica. Malpica, there was a price for the turbines. The main reason of the price is in the secondary market. There are some countries are requesting this kind of turbines, so second-hand turbines. In Italy, for instance, if you install a turbine under 100 kilowatts, you can have some kind of premiums, and then they make more attractive the second-hand turbines. So I think that it doesn't exist anymore. But now the second-hand turbines can be installed in third world countries, and also in merchant plants. As far as as I said previously, the trend is to install wind farms to sell directly in the spot market. You can get cheaper turbines, then it could be attractive to install even in Spain. The problem here when you install these second-hand turbines is the production is half. So comparing any wind turbine, a new wind turbine, the production is divided by 2, and then the price of the turbines will be also divided by 2 at least. And this is not so easy. So now the market is the price of the existing wind turbines is even is not half of the new one. And so the conclusion, the price of the existing wind turbines or the dismantle wind turbine will be variable, and will depend on the market conditions, and these market conditions can change year by year. But at least my surprise is the price of the now in the recently dismantled wind farm, the price has been higher than expected. The next one.
Alberto, only to add something to your comment, one of the issues that we have in the past concerning the second hand is that we could buy second-hand turbines, but for sure we didn't get any kind of guarantee, and because of that, we didn't get the finance from the bank. Luckily, these have changed, and now there's some companies that are offering second-hand turbines together with a certain guarantee. Because of that, the banks have changed a little bit their attitude. Now it's easier to build the wind farm with second-hand turbines.
Okay, so here you can see this is an answer to the previous question about the cost of dismantling, about the 20 euros per kilowatt or between 1–2% of the investment. But I want to insist that and this was covered by the payment of people who retires who get the existing wind turbines. But now it was an additional income. It covered. It was the income. It was even higher than the cost of dismantling. But this is not going to. This is not going to be in the future. And now will also, as Iñigo mentioned, it will depend also on the state of the turbines. There are existing wind turbines that are really well maintained, and there are still components in the market. Or other wind turbines are coming from non-existing manufacturers, and then it's going to be more complex. Dismantling also should follow the possible loss of profits. Normally, the existing wind turbines are in really good conditions, and you need to dismantle in the summertime periods, for instance, and then you know also to take into consideration. And all the administrative permits have to be evaluated. Normally, in Spain, there are not many all wind turbines with concrete towers. But in Germany, some repowering has been done, destroying the tower. So now the existing wind turbines are still towers, and the tower is reused. But if you have concrete towers, then it's more complex, and these towers, in the case of Germany, were completely destroyed. Taking the case of Malpica is a really good example, and quite recently it started the operation in last year. You see here that the turbines were replaced. Ecotechnia wind turbines, in total 69 turbines, were replaced by only 7 turbines, so it was divided by 10. The area affected it was also reduced, and also important in this case, you can see the figures. Some of the wind farms, the new wind farms, are half of the wind farms are installed out of the Natura 2000 protected Natura 2000. So there are improvements. The Malpica is an area, is a site with really good wind. Someone mentioned they have lost the audio. I don't know why. There are no problems with the audio. No? You can hear me? Okay. So there is the area has been reduced in this case, and also, as I said before, the production it was the double. Then and the rotor is now in this case is 92 meters and 92 meters. It's true that it's an area of class 1, and then you cannot use whatever turbine you decided. Okay, next, please, Nacho. So this is the case of Malpica. So here there is this part is in Spanish. I don't know what this was. Well, it was more than 4 years for all the permits, to obtain all the permits. It takes time. So if the decision is being on dismantle and repower the wind farm, then it's important to start as soon as possible, because it's going to take time to obtain the approvals. At least in Spain, we have different administration involved. There is the environmental agency for the environmental issues, but there is also the municipalities. As far as these are merchant plants, they don't need to get access to the Ministry for Industry, so there is the autonomy can proceed. But once the project starts the operation, they need to contact the the representatives to sell the electricity in the market, and also to there are some stages to be registered in the market, in the ministry, but it's going to take only 1 month, so 1 or 2 months. So you decide, you think that it's necessary to start, at least in our country. This could be to take at least 4 years from the very beginning up to the initial construction of the wind farm. Next, Nacho. Here there is one question I'm going to see. Question Spanish. How friendly are public authorities to repowering and install capacity? So in general, the authorities in Spanish are. So this is an important question. What the question is? What is the behavior or what the reaction of the authorities? The authorities, in principle, they were in favor of repowering because they think they can install the wind turbines in the best places and the best wind conditions. They can improve the generation without increasing too much the total power. Now they are more neutral. And even there is in Spain there is a situation in the past, in the first auction, repowering it was promoted. In the second and third auctions, this was not allowed. So I wouldn't say there is a clear strategy in Spain. So now it will be more neutral. For instance, in the case of Malpica, the Galician administration was in favor in principle because it was the replacement and the installation of new wind turbines. But finally, they lost a certain money of the canon because there are less wind turbines than before. So here you can see how to dismantle the wind farm. So it takes time. You need to have in summertime is better because to use the crane, the wind speed should be no over 12 meters per second, and the different components are being dismantled and they are assembled to the storage systems. Comparing the case I mentioned before in Germany, the concrete tower, they were destroyed with the use of explosives. Here, in the case of steel, you can integrate the different chances. It's true that you need to also take into consideration there is not a stairs inside the tower, or there are some components should be dismantled. But to transport the system is much easier. Next, so here there's the material is stored. In the case of Malpica, it was an action also to sell the wind turbines. You see at the bottom the different how the tower is integrated. So the transport of this wind turbine is very easy. Next one. The foundations should be eliminated. There are small foundations, so on the ground could be has to be recovered. So we are in our training course. We are going to present different cases. In general, you need to dismantle all the civil works, the foundations you have there, but in some cases can be also recovered. And it's also recommended when you have the new wind turbines to install them close to the existing. Even if you cannot use them, you need to install close to the existing foundations. Next one, Nacho. About recycling, yes, it's just a very overview of the recycling. Recycling in the case of wind turbines is could be feasible, especially for electrics and electronics. Polymers and composites is more complex. There are many projects around the world to recycle or to reuse the composites, but well, there are still some difficulties, especially to create the reuse in other components that are not going to be reused in the wind sector. Next one, we have still 10 minutes. Which are the conclusions of this presentation? Here in the presentation, we are just presenting some general ideas about we're going to stock we will enter, of course, in the details in the training course. So just is to awake your interest in this area. I would like to say that this, I said that before, that this is a rather new initiative. and I will hope to your reaction to this initiative. At the end, I think there is a poll is going to be in the site. You please give your comments to this training course, because it's going to be useful for us and also for InnoEnergy. So in conclusion, repowering is very viable and very depending on the countries, but normally that we see in the market is not a trend, because you need to invest. You need to carry out new investment. So the main reason is to increase the generation. The double to have this high rotary emitters will allow to increase the production. It's true that we can get additional support, so we can simplify all the administrative procedures. But as far as we know, we see it's not necessarily a real ministry implication. In general, to take a decision about the extension of life on repowering, it's important to get the data. Once you have the data, you can use the different simulation models to evaluate the remaining life. So it's true that the idea is to combine combining the numerical models. It's true that now there is a lot of initiatives around the world, but this is better to have clear ideas before to start, because otherwise they are going to be time and money consuming. Well, we will see in the market now. The idea is to initiate a life extension program before the 20 years. Now, when the wind turbine has 12 or 15 years, already is important to have a program of extend the life of the wind farms. Includes also the load calculations and the life inspection. So now we are going to present in this the remaining 5 minutes. There are some questions here. We will try. I'm going to conclude, and we will take it later. Iñigo, you can help me in answering the questions here.
Yeah, I'm doing so, Alberto. I'm answering to Laura now about the cost of the dismantling of the wind farm.
Okay.
To her, she's asking how should be included the associated cost to dismantling in the financial model, and I have already answered to her that normally, as in general terms, it's included in the financial model 3% to dismount the project, normally as a bank guarantee, as well as its original project in the original project, how to dismount the wind farm.
Okay, so there's some autonomous communities in Spain. They have also some bank guarantee of 3% for dismantling. But this is clearly very high. So because the cost could be 3%, we mentioned 2%, but you can also compensate with the cost within the income from selling the second-hand wind turbines. So entering now in the training structure, of the training course we will announce in the near future. We will have 3 different modules. The module 0, it will be the introduction and basic concepts. In total, it will be 8 hours plus 10 minutes of general presentation. This could change in the future, because we will see. We are now preparing the training course, and we will see how to organize it. But the course is going to be around 40-45 hours of online different classes, or different. So in total, between 40 and 44. There's one, Nacho. So no, this is conclusions. Please, the next, not the previous. So the first is the module. The first module, the module 0, is going to be basic concepts. We know that many of the potential students or attendees are going to be, they are already knows the main concepts of the wind energy, but it's important to give a general presentations about the main components of or the components of the wind turbines. It's true that in the case of life extension, we are going to concentrate our attention on the structural components, but in general, we are going to present an overview of the wind turbines. Also, we are going to present in the basics the wind farms. Once we have presented the wind turbine, we are going to present also the main layout of the wind farm. And the SCADA also, we will enter into detail on the SCADA, because the supply of data from the SCADA is always important, to supply data to fit the simulation models, and also to make to evaluate the decision if we go ahead with the wind farm, or to dismantle and repower the installation. Also, the fault trees, we will see some examples of fault trees to evaluate what are the reasons of the faults, typical failures, the metrics, and the contractual models. As I said at the beginning of this webinar, we will one of the situation in the market now is, once you have decided either to extend the life or repowering, is to adapt the models of the contracts to the new scenario. We will enter into details. We don't want to enter into details, but we will see which kind of contracts are the most common in the market, and it could be useful for the students if they want to initiate their professional life in the maintenance sector. Next one. So the second module will be the module A. This module is going to be oriented to the life extension. So we are going to explain what are the main characteristics of first a general presentation about how to carry out the life extension assessment, but to enter later on in the life extension assessment procedure. That means about elastic models, big data, combination, hybrid models, combination of both. Also, the condition monitoring is in condition monitoring and the SCADA we have seen before is the way of obtaining data to feed up the models and to get conclusions about the procedure to follow. And in this following classes, we are going to enter into the different. Sorry, Nacho, the following one about the different. No. Keep the previous. This one. We are going to enter into the different components: mechanical transmission, gearbox, plates, electrics, power electronics, foundations. Well, in general, as I said before, the attention is mainly concentrated on foundations and the structural components. So we will extend some of the other structural components here not mentioned. We will put also some other classes for platforms and also for towers. So how to evaluate the situation of the tower and how to proceed with the maintenance. The following classes are going to be concentrated in the procedures for guarantee the extended life of the wind farm. Also the specific actions. It's true that the decision is going to be taken following the income. So it is different. You are forecasting an electricity price for the future, and so it's not the same to have like in Germany. You have an average spot price of 30 euros per megawatt hour compared to Spain that we have 40 now. No, so then we are going to enter in some details about how to evaluate the electric price for the future, especially now that the European electric market is being integrated. Also the certification procedures. Now that you know there are different companies offering this certification, and also how this going. The methods to certificate. And our last class, you can see clearly now in the slide, is the health and safety. We consider that health and safety in general is very important in this sector, and life extension have some implication, especially when you are over 20 years. The things of not only well, safety is important, but not only for people working in the wind farm, also for third people. And health and safety here and also repowering are going to be two important issues. The following slide, Nacho. So this is going to be the different video classes for the dismantling. We are going to present something about repowering, more extended than we are presented today. Also, the general legal conditions. In the case of repowering, legal conditions are much more important than in the case of the life extension. Also, the social and local impacts are going to be evaluated. The people who are receiving a rent, for instance, are going to receive less rent because the number of turbines are going to be reduced. How to evaluate this social and local impact are going to be mentioned in this following class. Also, the economic and financial models in the different scenarios of prices and also the cost of a wind turbine. Here we will take into consideration the possible incomes due to the sale of the existing wind turbines. The insurance will also be considered in the extension of life, how the insurance will react to the new repowering, the new wind farm. The dismantling, also insurance has something to say in all these dismantling procedures, the same way that the health and safety. The reuse of the conditioning of the different components will be also here evaluated, how the different electronics, electric and composites materials, how are going to be reduced or recycled. And one thing that was mentioned by Iñigo before is which one the second-hand wind turbines installed, what are the implications for the financial health and safety and insurance companies. The land recovery, as we said before, we see in the case of Malpica. And finally, the recycling of materials and also the health and safety. Okay, so this is, we wanted to present now. This is a first introduction of our training course. I hope you will be informed in the near future about once the course will be ready. I'm sorry by the problems with the presentation. I had no problem. I had no problems, so I proceed because I have only will react. We will see in the chats and comments from your side. So here we have a quick question, please. It takes only 2 minutes. We would like to receive some react. We would like to see if this kind of course could be interesting for you. Next rep, the extension of live rep course could be interesting for you. Please send us the answer, and collecting all the answers, we can have a clear idea about the market potential of this training course. We have prepared. So thank you very much to everybody. Thank you to Iñigo and Nacho for helping us in doing this presentation. We hope to be in contact in the near future. Thanks, everybody. Okay. Have still some questions here. Nacho, how you answered?
Yeah, I have answered, I think, all of them, Alberto.
Okay.
No, we don't have up to now. Mainly the main questions are concerning the presentation. Okay. And we will forward the presentation and the demand from Nacho. And yeah, thank you everyone for joining. Sorry for the inconveniences. I mean, we have to change a little bit the presentation because some technical issues, but thank you everyone.